This is part 2 of section 2.7. We want to find the inverse of the function f of x is equal to 2x squared minus 3. And then we may need to restrict the domain if we do not get a function. So let's start off. We're going to change this f of x to a y. Okay, and then our next step is to switch our x's and our y's. So that gives me x is equal to 2y squared minus 3. Now we want to solve this for y, so add 3 to both sides. All right, and now divide both sides by 2 so that the y squared is by itself. So I'm going to flip this equation around. I have y squared is equal to x plus 3 over 2. Now we can use the square root property since we have something squared equal to something else. So I'm going to take the square root of both sides, but remember when you do that, you have to put a plus or minus in right there. So I get y is equal to plus or minus the square root of x plus 3 over 2. Okay, now here's where we have an issue. If you recall when we first talked about functions and we decided whether or not an equation that we were given represented a function or not, what we worried about was having a plus or minus when we were trying to when we solved it for y, when we're just looking for a function. So it turns out that even though we found this, it's not a function. So I do not have an inverse function the way it's written right now because I get two answers when I plug in one value of x. And so what we have to do is we have to figure out, we can't have plus or minus here, so we're going to have to restrict the domain. And I'm not allowed to take the square root of a negative number either. So when I go to talk about restricting this domain so that I have a function, I have to worry about x plus 3 over 2 being greater than or equal to 0. Okay? Because we're not allowed to take the square root of a negative number, we are allowed to take the square root of 0. I'm going to multiply both of these sides by 2, and of course 0 times 2 just goes away. So I have x plus 3 is greater than or equal to 0. Move the 3 over here. X is greater than or equal to negative 3. Okay, so as long as I use the domain where my x values are negative 3 or greater, so from negative 3 inclusive to infinity, then my inverse function is, I get to drop the absolute value here, I mean not the absolute, the plus or minus. This is taking care of that. X plus 3 over 2. So if I restrict my domain here to this, then this is your inverse function. Okay? Now, it's normal to wonder if there is an easier way to decide whether or not the equations you are given have inverse functions. And there is. There's something that is called the horizontal line test. Just a side definition, okay? Functions that have inverse functions are called one-to-one functions. Now, this is a function. It's just not a one-to-one function because this, without restrictions, did not have an inverse that was a function. But the other problems we did not have to worry about restricting the domain. So our original functions on the others were one-to-one, okay? This one we had to restrict the domain so that we ended up with something that's one-to-one. Now, how does the horizontal line test work? It's almost the same as the vertical line test. Remember, with vertical line test, what we were looking for is whether or not something was a function or not. And we imagined passing a vertical line through it, and if it ever hit more than once, we did not have a function. The same thing happens here, except it's a horizontal line instead of a vertical line, okay? So in order to have a one-to-one function, it has to be a function, so it has to pass a vertical line test. But it also needs to be one-to-one, so it needs to pass a horizontal line test. So let's look at these two imperfectly drawn graphs here, okay? Tried to draw a parabola here, but I ran into issues, but you can use your imaginations, right? Is this a function? Yes, as you go through it, your vertical line never hits more than once. So this is a function. Is it a one-to-one function? No. If you pass a horizontal line through it, it often hits your graph more than once. So this is not going to have an inverse function. So this is not, we often use 1-1 because mathematicians are lazy, and if we can come up with shorthand, we do. Okay? What we had here, up here was a parabola. And so it does not pass a horizontal line test. What we did when we restricted the domain is basically we chopped off this part and said, okay, we're only interested in this part. And then in this part, if we ignore this part, it is one-to-one because we never hit our graph more than once, which is what enabled us to do this. Okay? So a basic parabola is not one-to-one. Okay? And so it's not going to have an inverse that is a function unless we restrict the domain. This is basically your cubic, and it is a function. If you pass a vertical line through it, it gets pretty steep on your curve here, but it's always moving out, so you never hit it more than once. And as you go through with a horizontal line, you can also see that we never ever hit this thing more than once. So this one is a function because it passes a vertical line test, but it is also one-to-one. Okay? So all of the stuff that we've been doing sort of ties in together. If you can look at an equation and know its basic shape, then you will know whether or not it is one-to-one. And if you know whether it is one-to-one, then you know whether or not you have an inverse function. It's all tied together. These are not separate topics.